मैं तो मैं तो बोलूंगी कि सर आप एक काम कर लीजिए, अगला सेमेस्टर आप ले लीजिए, आप पढ़ेंगे थोड़े 800 बच्चे तो डायरेक्ट
Yeah, hi everyone. Am I audible?
Hello, Vijayanand sir. How are you? Good evening.
Hey, Murli. Good evening.
Thank you very much for joining on advance.
Yeah, no problem.
Um,
So I am audible, right? And
yeah, you are very audible. Yeah.
okay, cool. So Murli, let me see whether I'm able to share my content and
Let me give you the access
okay,
so that you can share the screen.
okay, sure. Okay.
Good evening, sir.
Yeah. Good evening, hello, ma'am.
So,
How are
dear
you?
participants, yeah, I'm good, sir.
Yeah,
And
okay.
happy to have you here as one of our speaker for the session.
Okay, thank you. No problem.
So, good evening, participants. We welcome you for another enriching, informative session. So, it gives me immense pleasure to introduce our distinguished guest speaker, Mr. Vijay Anand Senniyappan, Senior Technology Architect at Infosys Limited, Chennai. So, Mr. Vijay is a highly accomplished technology leader with over 2 decades of experience in architecting, designing, and leading the development of large-scale enterprise platforms and applications. His expertise spans around .NET technologies, cloud architecture, and emerging AI and ML solutions, making him a true innovator in the digital transformation space. So throughout his remarkable career, he has worked with several global clients, including Microsoft, Dell, PepsiCo, Bank of America, and Heineken. So delivering impactful, scalable, and secure solutions across industries such as high-tech, retail, and financial services. So notably, Mr. Vijay played a pivotal role in architecting Heineken's global B2B e-commerce platform, which is now successfully deployed across 26 plus international markets, streamlining operations, loyalty programs, and promotions. So beyond his technical expertise, he is also a mentor and thought leader, driving excellence in architecture modernization, developing optimization automation, AI adoption, and performance optimization within enterprise system. With a strong passion for innovation, Mr. Vijay continues to explore generative AI, LLM-based solutions, and agentic AI to enhance business operations and customer experiences. So we are truly honored to have him with us today to share his insights on cloud architecture and AI-driven expertise solutions. So please join me in extending a very warm welcome to Mr. Vijay Anand Senyapan from Infosys Limited. So we welcome you, sir.
Welcome you, sir.
Yeah, thank you. Hey, thank you, Anu ma'am, for a very nice introduction. You saved my time today. Thank you so much.
Over to you, sir.
Can we get started, or you want to wait for some more time?
No, sir. You can start, sir.
Okay. So I will share my screen. Okay, and okay, so I'm sure. Okay, is my screen visible to you?
Yeah, sir. Your screen is visible, sir.
Just give me one, let me. Okay, I'm switching off my video and for some time
Sure, sir.
until,
Sure,
until
sir.
I complete the presentation. Okay.
Sure, sure.
Okay. Thanks everyone for joining today and spending your wonderful evening time with us. And so, as Anu said, I'm Vijayanand from Infosys. I'm Senior Technology Architect and I'm based out of Chennai. And today we are going to see the topic modeling using LDA. Okay, let's see and what is topic modeling, right? And how it works. And topic modeling is the one of the unsupervised machine learning model. So when you see all the machine learning models, majorly it will fall into two type of learning models, right? Supervised machine learning model and unsupervised machine learning model. When you talk about supervised machine learning model, where we teach or train the machine learning model with a known data or labeled data. For example, if you want the machine learning model to detect the pictures of the dog, you will train the model with various type of dog pictures, right? And different colors of the dog, black color dog and white color and brown color, and different breeds of the dog, right? Alsatian and Labor dog, and the dog who is eating, sleeping, and playing, right? So you will feed in all type of different dog pictures to the machine, so that machine will learn on its own, right? And then when you give a new picture of the dog, then it will be easily understand and tell that, okay, this is a picture of the dog, right? That is called supervised learning, where you are training a model with a known data under your supervision, right? When you talk about unsupervised learning, when we don't know, when we have a unknown data, right? When we have a data and we don't know what is underlying information for those data, and also unstructured data or unlabeled data, right? You can call it in any terms. So when you have unknown data, and so you want the machine learning model to understand and find the information you are looking for. So the topic modeling is one of the unsupervised machine learning model, right? And what it does, so it will find when you have a large corpus or large volume of the text documents or text data and unstructured data, And a topic model will help you to find the hidden themes or interesting informations cooking underneath the documents, right? And it will identify and tell it to you, right? That is what the topic modeling is all about. And so it works on the intuition that if you look at any text document or text data, and the intuition is that each document will have one or more topics, right? And each topic will have more number of words. Okay, this is the intuition. Something like the book has many chapters and chapter has many words, right? So this is the intuition behind and how the topic model works, correct? So each document will have more than one topics or one or more topics, and topic will have more number of words, right? When we have a large volume of data, so all you have is the document and the words, right? So topic model will slightly work in a backtracking mode, okay, and it will find the words which are frequently coming together, right? And the words which are co-occurring together, right? And then it will try to put those words into the same topic, right? So it will backtrack, it will find out the words which are coming together or giving similar meaning. It will try to put them into the same topic. In this way, it will find the topics that are there in the each document, right? So this is the intuition and this is the high level logic the topic modeling works, all the topic modelers, right? So with this understanding, and we'll see where and all the topic modelings are used in a real world scenarios, right? Some of the real world scenarios or use cases I have given here, it's not limited to only this. And if you have any specific requirements in the application you are analyzing or checking, and you can have your own data also, right? But these are the broader categories where the topic modeling is becoming very useful and handy, right? And the customer feedback, right? And the product reviews, right? Especially in the e-commerce platform, the people are buying the product and giving the review. And there are survey responses, right? In the any organization, any educational institution, you are getting the survey. Even in the government organization initiatives also, we're getting a lot of survey responses, right? And any application, any products, people will be reaching out to customer support desk and creating a lot of customer support tickets to investigate and resolve the problem, right? And any social media comments or the posts, right? These are the typical customer feedback data. So we don't know what this data is all about, right? And if there is social media, what is the current trend of topic going, or current topic is currently going on, and if it is a support ticket, what is the recent issues and which product is having more number of issues, right? And product reviews also, right? Which product is good and affordable and so on. So the topic model will come handy here to find the topics that are being talked about in this data, right? And then similarly for recommendation, right? And it will aid the search, right? And instead of doing text search, and it will find the high level topics, and then that will help in the recommendation system, right? The recommendation is like any product you are buying, and it will give a recommendations. Any course the people are taking, then it will give a recommended courses, right? So it will help in the recommendation system also. And market analysis is one of the area, and there are a lot of data available for the competitors and sentiment of the people, right? And the industry trends. So the large data is available, and you have to find out the interesting topics so that you can do better marketing for your own product, right? And similarly for academic and summarization. When you have a large document and without reading the document, you wanted to know, right? And what are the important informations or high level details, right? And that summarization use case also, we can use topic modeling and also document organization, right? Huge number of documents, you wanted to group the documents into each category, then topic modeling will be useful, right? This is not limited to these use cases, but these are the broader use cases where we can use the topic modeling. Okay. Hope I'm audible and clear.
Yes, sir.
Okay, good. Thank you. So it's little theoretical. Before I give the demo, I wanted to give some context. That's the reason I'm talking from the theoretical aspects. So topic modeling, and there are various topic modeling techniques available, and these are the commonly used topic model techniques. Okay, LDA is one of them, and LDA stands for Latent Dirichlet Allocation. And there is a guided LDA, and there is a NMF, and there is a bird topic, right? And each one has its own pros and cons, and depends on the situation and depends on your own requirement and the data that you are analyzing and the information you wanted to retrieve, and you can choose one of these topic models, right? And LDA is a very common and general purpose model, and it's lightweight model as well. And bird topic is a very modern one by using the transformer and architecture and clustering, and use LLMs also to some extent, correct? And for LDA, it's a traditional models which works based on the probabilistic techniques, and it is used. It's there for quite some time. I think it's since 2007. It's there. It's broadly used, and it's easily interpretable, and it works well with a large corpus of data. Okay, and it may struggle for the short text, right? Very small, the document or the data has very less number of words, then it may struggle to find the topic. But when you have a large corpus, it will work well, right? And since it is working based on the word co-occurrence, okay, so some level of word context it won't be able to do like about topic or LLMs, right? So there is a limitation for LDA, and moreover, it will find the topic, and it will each topic it will give the words that are falling into the topic, but it will not be labeling the topic. Okay, so you have to infer from the words that are presented for each topic. Then you have to come up with a labeling of the topic. Right, that is same for guided LDA and the NMF as well. And per topic is, since it's advanced, it will be able to tell the topic name as well, right? And guided LDA is another variation of LDA. It's LDA, but it's another variation where when you have a good domain handle or domain knowledge of the applications or any data set that you're working on, and you can tell, okay, these are the possible topics, and each topic, and these are the possible words that may come under, right? So you can see that information to the LDA. So LDA will try to converge the documents or converge the topics into any of the topics that you have already given as a feed, right? So that is that will become very helpful when you have good domain knowledge, and also the data that you are analyzing, right? And you have some good understanding of the data, then you can go for a guided LDA. So NMF is another variation, another mathematical model. It's based on a linear algebra model and matrix factorization technique it will use. And so it will improve the coherence of the topic, meaning, and the words that are coming into the topic, right? And it will be more coherent, right? And it will be more similar, or the similarity between the words will be better for the NMF model, but the interpretation will have some challenges, right? And BERT is the modern technique, and that it will use transformer architecture, which is used in our LLMs like a chatbot, Gemini, and all. And it will use clustering, right? And it will work well, and it will be, because of the architecture in nature, complex architecture in nature, the computational power will be more, right? And so you have to choose this when you have high quality data or complex data, right? And where you want to have high accuracy, and you can still afford to spend more money, then you can go for a board topic, right? And today we plan to cover some part of board topic, but we'll see. But the focus is for LD. So any questions so far before we dig deeper into LDA? Okay. Since I'm in the presentation mode, if there are any questions in the chat, I won't be able to see it. And so probably you can speak up. Okay. Hope everything is clear. Then let me move on to the next part. So this is another viewpoint, and how the LDA works, right? And you have a collection of documents. So So you have a collection of documents, and the documents, when you feed that documents into the LDA algorithm, and the LDA will find one or more topics within the document. And here, if you have 3 documents, the document 1 has 3 topics, and document 2 has only 1 topic, and document 3 has 2 topics, right? And put together 3 topics. Okay. So we will see how LDA works. Okay, so it's very high level information. You are having the documents, and the LDA will convert the documents into the topics and topics into the words. So how the LDA works? Okay, so for any Word document, right? Any Word document in a vector space, you can represent it as a document term matrix. Okay, so the document has a words, and this can be represented as in the matrix format. So it's called document term matrix. And assuming you have a 4-word document, and there are some 5 words, and some document has 4 words, some document had all 5 words, right? So this can be represented as a document term matrix. So LDA, using probabilistic technique, okay, it will reduce the dimensionality of the matrix. In turn, it will create a 2 low dimensional matrix. Okay, it's a document topic matrix and a topic word matrix. The first matrix M2, it will tell each document what are the topics there. So assuming that the topic, I mean, all 4 documents, we have identified 3 topics. So it will have a each document, what are the topics are there, right? And similarly, the topic word matrix, and each topic, and what are the words there, and how many times the word has occurred. Okay, so the objective for LDA is to convert this document matrix. This is what we have, right? Document words. So we wanted to find the document topic matrix and the topic word matrix, right? And the LDA does that. Okay, and so it will randomly do this distribution. Okay, and then it will improve over the period of time by doing the sample iterations. Okay, so at this point in time, and just assume that there is a document term matrix, and LDA will be converting into document topic matrix and the topic word matrix. Okay, so how it is doing? Okay, so it uses first, initially it will do the random assignment. Okay, for each word in the document, it will randomly assign to different topics, correct? And each word it will assign to 1 topic, right? And randomly it will do the assignment first. And that the random assignments will not be accurate, right? We know that. So random is not accurate solution. And but to start with, we'll do the random assignment. Okay, and LDA uses sampling technique called Gibbs sampling, right? And by using the Gibbs sampling, it will reassign the word to the topic. Okay, how it will reassign the topic? I mean, how it will reassign that word to the topic by using probabilistic technique. Okay, and there are 2 probabilities, P1 and P2. So first probability will tell so how common the topic in the document. Okay, the topic, the document have 1 or 2 topics, right? And how common that topic in the document, right? So probably the document will talk about sports majorly, and also it will talk about safety, right? Very minimal. So, but the sports is the major topic in the document, correct? So the P1 probability will tell how common that topic in the document T. There is a P2, how common the word in the topic T. Okay, so if the goal appears in the sports topic, even though it appears in the different document, most likely it will fall into sports, right? And how common the word in that particular topic. So that will give a, the P2 will give that probability. So multiplied, I mean, we have the product of P1 and P2 will give a overall probability of the word for that particular topic. Okay. And then it will, based on the probability and which topic is having more probability for that word, then the topic assigned to that particular topic. Okay, this process will be repeated until it converges, right? After some point in some iterations, the assignment will be very minimal, or there are no reassignment happens. So in that state, it is the convergent state. Okay, so we'll look into that with a small example. So assume there are two documents, right? One document is having apple, banana, apple. Okay, and document 2 is having car, engine, car. So the first document talks about fruits and second document talks about automobile, right? So any and assume that there are two topics, right? Here, just looking at the word, and we will be able to understand there are only two topics, topic A and B, and the vocabulary is only four words, right? Apple, banana, car, and engine. Okay, so then initially we will do the random assignment. Okay, we'll take a word apple in the document 1, assign to topic A, and the second word will assign to topic B. And third word also apple and assign to topic A. Similarly, car is topic B and engine is the car topic A and the car is B. This is a random assignment you have seen, right? I mean, there is no intelligence required here, and randomly we will assign the word into each topic. Okay, this is a random assignment, but this is not accurate, right? It's not going to give a right information to us. So then we have to iterate by using Git sampling and see how the topics are getting reassigned. Okay, let's look at the word banana at the position 2 in the document 1. Okay, so we'll find the probability for topic A. So there is a probability 0.5, right? I'm not doing the calculation, mathematical calculation here for the interest of our time. But if you go with this, right, and okay, if you go with this one, P1 and P2, and there is a formula available. So for the banana 2, and probability for the P topic A is 0.083, and topic B is 0.041, right? And the topic A has more probability. The banana word will be reassigned to topic A. Okay, like this. Similarly, for all the words we do it. So this is one iteration, and for car also. And if you look at engine, right, then based on the probability, it may reassign to topic B. Okay, and so since it's a very small corpus with a very few words, but the large document with large words vocabulary, it requires a lot of iterations, okay, to converge. Right? And apart from this probability, there are some hyperparameters in the model, like alpha and beta. This is majorly used for avoid the zero probability, right? So if the document is not present, then probability will become zero. To avoid that zero probability, the alpha beta are used, right? And the probability formula will include alpha and beta. And vocabulary also is used in that formula. And the alpha, I mean, for this calculation, we have used alpha 1 and beta 1 to avoid the zero probability. For that, the alpha will decide or um, um, uh, will decide how many topics each document can have, right? I mean, so if you have a higher value for alpha, the document may be having more topics, right? And the beta is for words per document. The higher the value is beta, the more words will be present in topic. Okay, so by adjusting this parameter, then we can get into the good state, final state of the model. Okay, so we'll see that in a demo and how this is used. And if you have a lesser value, that less number of topics will be identified in the document. And if you have a less value or more value for the beta, and more words will be identified for the topic. So these are the parameters, hyperparameters that can be used and fine-tuned at the time of executing the model. So any questions here? I mean, this is very high level viewpoint, right? How the LDA works, without getting into too much mathematical. And there are two probabilities that are used to um, find the right topic or near close topic for each word. Right? It will not happen in one iteration. The multiple iterations, it will be getting into the convergence too. Any questions clear? Okay.
Sir, I just want to understand. You're talking about documents and then the words. Little abstract here. Is it like clustering the secondary data into buckets? Something are we trying to do that?
No,
Is it
clustering is
clustering?
yeah, something similar, but the clustering is that each document will be going into one cluster, right? So here in this case, we wanted to find out more topics in the same document. First, we have to find the topics. Clustering is more like you will identify the document and you will find that you will assign the document into the respective cluster, right? But whereas the document may have more than one document. So the same example I have told, right? And the document will have sports majorly and safety aspects very less, right? But this document will be in the clustering technique, it will be moved into cluster, sports cluster. But it has a topic for health aspect also or safety aspect also, right? So the clustering will not be able to find that. Whereas in the topic modeling, the document will have more than one topics and it will be able to find out. It's more like a close to clustering, but it's more than clustering to identify more topics in the same document.
Sir, we're trying to get some idea, but the real time application of this technique, hello?
Yeah.
Yeah, okay, sir. Somewhere on the real time application, if you could throw some light on that.
Yes, sir. If we could get some hands-on on this topic, we may understand more rather than having this. Yeah, I understand that this theory is essential, but if we have some hands-on, it would be much more easier for us to understand how this works and what would be the output and what is the difference between this and clustering and things. Thank you, sir.
Yeah. So we have a
Yeah.
demo. We'll go through that.
Yeah, thank you. Thank you, sir.
Okay. So this
Sir,
is
if you have a content, you can go ahead. Or any process you want to talk.
no, I will cover
Sir,
this.
can you hear me, sir?
Yes. Yes, Murli. Am I audible?
Yes,
Hello?
sir. You're audible.
Yes, sir.
Okay. So I will cover this overall process, then we'll get into the demo. And okay, so for LDA to work, right, and we have a data, and then you have to load the data, load the clean data, right? I mean, whatever the data we are getting, and there is some kind of a cleanup required and encoding and so on. Once we have the cleaned up data, and there is a pre-process step is required very much. And this will help us to give only the essential information going into the models, right? And there will be a lot of noise there in the data, and the pre-process will help us to reduce the noise, right? Some of the steps that I have given, but it's not limited to only these steps. Depends on the data set, right? The initial analysis you have to do and then find out what are the noises you have to remove, right? And the tokenization is a basic technique, and it will split the document into multiple words. And removing the stop words in English, there's a lot of stop words which are having less meaning, like a, they, is, was, and so on, right? There are a lot of stop words, and then we'll remove the stop words. And some cases, right, and the n-grams are required, and the two words can be as a one token, right? And for example, the machine learning or lack of knowledge, right? In those cases, then we can use n-grams, and it depends on your data set, right? And not need for all the data set. And lemmatization that we do, and we convert the word into the root word, like a thinking is word, right? And then the root word will be think, right? So the lemmatization will help to convert the word into its root word so that we will have a unique set of words. And then we'll create a dictionary, and dictionary is like a vocabulary, right? And all the unique words will be part of the dictionary and it will be treated as a vocabulary. And then we'll create a corpus. The corpus is something like this, right? Sorry. The document term matrix, right? And how many words are there and how many times the words occurred in the document. Okay, so once we have done the pre-processing, then we'll create a LDA model. And once the models are created and the output has come, and we'll use some metrics to evaluate whether output is in a right state, right? And then we will use some inter-topic distance metric also. And there are these are the three metrics we will look into and see whether the parameters that we have given is correct and the topics and words identified correctly, right? Perplexity is one metric, and the lower the value is better, and the how surprise the model with the new data, right? That is called perplexity. The lower the perplexity is, the better the output is, right? And topic coherence and the similarity between the words in the same topic is called topic coherence. The higher the coherence is better. The intertopic distance, right? And the overlapping between the topics is, if the overlapping between the topic is less, it is well segregated, I think this is good, right? Then we will see that, okay, so the topics are separated and it is giving some unique meaning. Okay, so we'll go to the demo, and so I have used news article from the Gaggle and ABC Australian ABC news channels data for last 10 years. Then we have taken, then I have used it for demo, and I am using Colab today, and I copied, since connect to the Colab Gaggle data directly from the Colab requires some user and user ID and password and key and so on. So I downloaded and I uploaded directly into the Colab. Okay. So with that, I will show the demo. Let me see one data. Okay, I think I have done some modification. That's okay.
Yeah, you can explain the data, sir, first. What is the data it is, and then you can.
Okay. So the data is, if you look at,
You can show the raw data first,
okay.
and then you can go for the collab, sir.
Okay, sure.
Participants, you can be hands-on from now on. When Mr. Vijayanand would have been completing his demo, you can also do the demo today. And I myself also, we can show that.
Okay, this is the ABC News data that I'm using it for demo today. There is one more data set I have also downloaded, then we can use it for hands-on. Since it's a large data, it's taking time to load. Okay, it has come. It's a news headlines from ABC News. This is a date in which news, right? It's news headlines. Are you able to see that?
Yes, sir.
It's Australian news, right? And news is talking about there is a community news, there's a political news, right? And then council, news about council, right? And news about death, some digital, right? And external affair news as well. So this is how it's a headlines data, and LDA will little bit struggle to work with a short text, but when you have a large text, then it will work well. And but we'll see how it will be able to find the topics between them. Okay, it's already cleaned up data. It's not having a lot of noise here. And is that fine, Murli?
Yes, sir. It is fine, sir.
Okay. So let's jump into the Colab. Okay, so I already ran it. Okay, so let me hope you guys are familiar with Colab, right? And Colab is from Google, and you can run the machine learning models. Okay, so to run the LDA, and some libraries are important. So Gensim is an important library for LDA, and this library is giving us to create a LDA models and work with the LDA models. So word cloud. So word cloud will help us to visualizing the data at the document and the overall corpus, right? And so what are the words that are very prominent in the corpus, right? And it will help us to do. And PyLDA Vis, right? It's another visualization tool to help us to understand the inter-topic distance that we talked about. Okay, so these are some important libraries that are needed for LDA, and apart from the MATLAB library for plotting, and the Pandas library is for data, right? Data handling and analysis, right? Then we can use Panda. And NLTK library for NLP related operations, right? The tokenization, stemming. Okay, so these are the key libraries that are needed for LDA. And I have installed the libraries, and then I have imported some of the library methods and objects. Okay, so then for cleaning up the data, then the stop words and stemming words, right? And that we have downloaded from NLTA. So this step is downloading that. So then we can read the data set, right? By using the Panda. The Panda reads CSV file and it you can give the path. What I have done is that, and I have downloaded from that location, the Gaggle location, and then I have shared that in Google Drive for this course also. And if you click on this, okay, it's taking time to load. So here you can create a folder. Yeah, so I have created the sample data folder, and here you can upload the data. And I have uploaded the data here. Since the runtime got disconnected, it's not showing any data. Okay. So here it shows the data, right? And if you go here, there is a 3 dot here, and then copy the path, and then you can paste it in the dataset path. Okay. So I think this is the correct path only. So for your exercise, and you can upload it into this folder, right? If you go to the content, the files location in the Colab, and you can create a folder and then upload it here. Okay, so the Panda will read the data set, and the head information will give the initial 4 or 5 rows, right? And what are the data available, right? And the df shape will tell you how many rows are there. So almost millions of rows are there, and I'm taking only 10,000 rows for demo purpose. And we need only the headline text column. We don't need the published date column. So for the data, we are getting only the headline text. So the data pre-processing, right, and removing the punctuations and removing stop words, lemmatizing words, right, and we created the functions, and by using NLTK library, and there is a toggle Gemini, right? So this is a AI generated um, uh, a Gemini tool, right? And you can use this to create a code for you. So you don't have to remember the syntax and so on. And if you wanted to perform sub steps, and you can use this to create a code for you. Okay. So once you have done the pre-processing, these steps will be doing all the pre-processing, right? And data apply. So after pre-processing, and this is how the data will look, right? The tokenization is done, and lemmatization and stop word removal, everything is done. This is how the data will look like. Okay. So now the data is cleaned up and pre-processed, right? And you need to look at the data, right? And analyze the data a little bit and see any further cleanup required or not. Okay, so I'm just checking what are the top words in that the 10,000 rows that I have added into the data set, and what are the top words that are available, right? And there is a police is the commonly used word, and these are the words that are used. So you can use the word cloud also and see the prominent words, and you use the bar chart here. So the police may be like it may be a law and order related topic or crime topic or any other topic, right? And Australia is appearing more because it's Australian news. Okay, the council more related to the political news, right? So this is a one data we can look at, one way to look at it. And also I wanted to, since this is the news headlines, and wanted to look at, right, and how many words are there in the each headlines. Okay, so this is a representation. This is again using MATLAB. So there are many more than 3,000 headlines having 5 or 6, right? And 4, 5, 6. These are the common words in the headline, right? And the some headlines data are having no, 1 word, 2 word, and 3 word and all, right? So probably these data may not be very much useful, and this is also not very much useful, right? Then these are the prominent data that we need to use it, right? Because many rows are having 5 or more words in the headline. Okay, so I did some data little bit cleanup after we did some exploration, and I am taking the headlines which are more than 3 words, okay, and less than 3 words probably may not be giving any meaning or topic. Okay, so after removal, right, then you will be seeing only 3 word headlines here. So now we are building the model, and then we have to create a dictionary. And so here I did some more filtering, and like any document, any word that is appearing less than 5 documents, I'm ignoring it. And some words that are appearing in almost all the document, right, and more than 80%, and I am removing it. But this can be adjusted and in order to get the right results. Okay, so this is a LDA model, and with all the default parameter I have given, but this alpha, beta, right, and these are the important, and the number of passes, right, and you don't want to do infinite times to get into the convergence, and I'm giving some number, and the 20 iterations I'm giving here, and the default value for alpha, beta I'm giving. Okay, so initially we have to give the topics. Right now we don't know how many topics are there, and we will start with some topic and slowly increase it and see, and how it is converging, and what is the how the performance metrics. If the performance metrics are better, then we will stop it with that topic, right? For the demo, I have done some multiple iteration and find the number of topics here, but you can start with lower number and slowly increase the metric. Increase the topics and see how the metrics are looking like. And the metrics are good, then probably you can stop with that. Okay, so I ran with that, and for 4 topics, and I printed some 20 words, right? And this is the first topic, and it has these words, right? And the second topic has these words, this number of words, third and fourth, right? And then there is a perplexity and coherence, and we find out the perplexity is low for the given data in the demo number that we have given, and coherence is also better. So then by LDA, we say this is a visualization tool. So if you look at it, there are 4 topics, and the 4 topics are well separated out. And there is one little overlapping is there, that is fine. And this is a better visualization, right? And if you go to that topic, next topic, right? And here you can see, so what are the common words in this topic? Okay, so it's talking about police, Australian woman, plan found, murder, right? And killed and all, right? It's talking about attack. So based on the words, then we'll infer that this is talking about some the court and report, right? It's talking about some law and order or crime related topics. Right, so this is something we have to infer, and that is why the subject matter expertise is required, or the understanding of the data set is required, right? And based on looking at the words, then we'll infer that okay, this is talking about some law and order or crime related topic. Okay, the next one you can see. So this topic is having words like this, right? It's talking about council and Sydney and market and election and state, labor, right? It's talking about political topics, right? So this is talking about something politics. The next topic this one is talking about water, hospital, health, right? And some national and price, right, and commission review. So it is talking about something related to the healthcare. So this is the 4th topic, and it's again there's some crash and government and rise and minister funding, right? It's talking about some finance and industries, right? So it created 4 topics from the 4 topic words, and we are able to at least infer that okay, this topic is talking about a specific subject. Okay, and then there is a word cloud visualization, and this will again, right, for each topic what are the prominent words, and the same way the different representation. Okay, so the inference will be a little bit challenging here, right? And but when you have larger corpus and some probably the clear cut words will help us to find the topic, correct? So since it's a news article, we are able to infer, but if it is unknown data set and subject matter expertise required there. Okay, so this completes the demo, and I created one more thing. Okay, this exercise I want you guys to do by using the data set called research articles. Okay, so this is having the abstract of the research article. Probably I will show the research article. So
Participants can come out with any doubts in between while the demo itself. I can also share you some files. You can do hands-on from now onwards. I think after this demo we can do. Am I right, sir?
Yes, yes. So this is research paper articles data. It is having data and abstract. So abstract is talking about what that paper is all about, right? So this data I have used it here. So okay, if you look at it, no, it's the same notebook, but I just changed the data and some cleanup I have done. I mean, this I am not taking. This has only the um, okay. There is the output and all. I have removed it, but so this okay. I will run it. It will take little. Do we have time to run it, Murali?
Yes, sir.
So do we have time to run this one?
Yes, sir. You can run it by
Okay, okay.
7:30. We can give them on hands-on. Half an hour they can do hands-on. We can just see that.
Okay. This one, this when you're running this command, right, it is giving a lot of warnings. So this statement will suppress the warning. Okay. So there is a run all option, right? Then you can run it and it will run the cell one by one. Okay. So if you look at it, this is the data set that is used. And I will explain it once everything is running, right? So
Sir, can you please explain using the abstract and titles data set what you showed us?
okay. This Excel sheet, this data.
Yes, sir. Yes, sir.
So this is the research article data set. Okay. So the various research articles that are there, right? And this article is talking about software industry and it's talking about natural language and big data and computer and it's talking about some different problems, right? And it's again neural network and this is again neural network, right? So these are various some mathematical topics also there and some quantum related topics also there. Okay, this X-ray related enrichment, organics. So this majority of the documents are software related, but there are some topics related to atomic. This is like a science topic, right? This is a science topic. Some mathematical topic is also there. Okay, so this is the research article papers on various subjects. Okay, and it's having title and it's each article it has some abstract. So the abstract is having some good number of characters, so it will help us to find the topics. Okay, is that fine?
Yes, sir. Yes, sir. Sir, for
Oh.
example, on a particular research domain, we have done the initial cleaning and we have developed this sheet, this what you showed, like title and abstracts.
No, this is the input data.
Huh?
This is the input data that we will use it for LDA hands-on to come up with the topics.
Yes, sir. Yes, sir. So after this means sheet, if possible, you can show us how this sheet can be loaded and developing that LDA
Yeah,
in
that's what
Collab, sir.
that's what that's what I'm showing it now. So I just ran all. This is the sheet, right? And I just ran all. I think all of them are executed, right? And just before I'm showing that Excel sheet, I just click ran all. So all the comments are executed. It's pretty much same as what we have seen for news article as well. So we have to install all the libraries that are needed. And this is for ignoring the suppressions, right? Sorry, suppressing the warning statements. And these are the libraries and import statement that we have to use for all the libraries that are needed. And again, punctuations. So loading the data sets. So we load the data set and the dataset head command will display the top 5 rows in the data. Okay, so we don't need the title and we need the abstract alone, because we are using the abstract alone to do the topic modeling. Okay, so I'm getting the abstract data alone, and then we are doing all the pre-processing, punctuation, remove all of them. And if you look at the pre-processing steps, and we are removing the punctuation and tokenizing we are doing, and we are removing the stop words. And this document, and in the news document, we don't have any numbers, right? But this document has numbers and some of the special characters which are not really required for topic modeling, right? And we are not going to do the topic modeling based on the numbers and so on. So those are less significant. So I removed the numbers, especially for this data set. Okay. And so then after the pre-processing, we are showing the top 5 data, right? This is how it has been tokenized. So the data exploratory again, and if you look at this, no, the model is prominent in the entire data set. And then there is a method, data, result, network, and problem, algorithm, paper, approach. Right. So these are I think majority of the papers are on machine learning, it seems. Okay. That's why the top words are all of them, most of them are related to machine learning. Right. And then we have taken the word length, right? And what is the length of abstract text? Right. So I think majority of that abstract text is more than 300 words. So which is good. And so I am removing any abstract which is less than 10 characters or 10 words. I am removing it. And because if the abstract has only 10 words, then it does not give any meaningful information. So I am removing it. And again, creating the dictionary, and I am filtering, no, I mean, any words that are appearing less than 5 documents, I am removing it. Any word that is appearing more than 80% of the document, I am removing it. Then I'm creating the bag of words, the corpus. And here I'm giving, I initially started with 2 and then I slowly increased it and I got into 5. And this parameter only you can change it for at least demonstration. And if you're still not getting the results, you can still change the alpha and beta. Okay, but I did change this. I'm able to get some inference. Okay, so we got 5 topics, and the topic one is talking about the quantum magnetic transition structure and so on. It's more related to the science topic. Astronaut science looks like. And this one is more like a machine learning, model learning algorithm performance, right? So the machine learning models. This is something like a user control study. So some research environmental study, control system related topic, it seems. And this is topic about energy, temperatures, and particles spectrum. Again, it's a science topic. Surface measurement, right? And it's more like a energy related topics. And fifth one is like a problem, result, space, numbers. It's a mathematical graph conditions, right? It's more like a mathematical topic, right? So at least 5 topics that emerges. And so again, we calculated this, right? This perplexity score is low and this cogredence score is better. And the visualization is also done, right? And if you look at the first topic, so these are the common words for the topic. No, these are mostly on model, method. It's a machine learning one, right? And next topic, function, problem, space, graph, and all, right? This is the mathematical one, right? And the next topic is like a system, again, user control, environmental. It's more like a control environmental science, right? Control system and environmental science related. And fourth one is it's like energy, particles, spectrum, again science. Okay. So this is how we are able to find some topics. Since it has a large corpus, it's able, at least we are able to infer into some topics, right? And but in news we have some difficulties because of the less text, right? But it has more text, we're able to infer something. So here also, if you look at that's the inter-topic distance is also better here. If you see more overlapping, then which means that you have to reduce the topic or you have to increase the iterations. Okay, so when you do this modeling rate, the topic probably you can start with low number and slowly increase, and you can keep alpha, beta, auto, and probably iteration you can increase iterations, right? The passes you can increase and see whether it is converging. So for every pass, right, you can check the score, perplexity score and coherence score, and also that inter-topic distance.
Shall we look into the research perspective, sir, if you have completed it?
Yes. I'm done actually.
I think Mr. Venugopal is also here with you, I hope so. Is it right? Good evening.
Yeah, Ivan.
Yeah. Good evening.
Yeah. Okay. Vijayanand sir, you can just come in a video so that we have a small screenshot.
Okay,
For
sure.
the input purpose, we will put it.
Can I stop the share?
Yeah. No. You keep the sharing and keep your video on. Just for a moment, I will just put a screenshot.
Okay. Since in I'm sharing mode, I won't be able to see this. Okay. Is it visible?
That is not an issue, sir. Just a minute.
Okay.
1 minute.
So Venu, you want to add any additional points?
I think you have covered everything.
Actually,
I just added few points in the chat.
Okay, cool. Thank you.
We saw that also. Yes, correct. Venugopal has told about some of the libraries, BERT library, which can be used. And what faculty would be very helpful is how this can be made into the research. That is what it is very important for them. Okay. So in that aspect, I will cover for the next 10 minutes so that you also can please stay here and you can also look how it is there in the research and you can just clarify the doubts. Let me complete it in some 10 minutes. Yeah.
Sure.
Just a minute, sir. I will just start sharing my screen.
So one doubt from my side. Shall I clarify, sir?
Yeah, please. Vijayanand, sir, please.
Yes, please.
Sir, how do we extract this kind of data, a high corpus data from any database, or from where we can extract this kind of data, sir? For doing this topic modeling?
No, generally, I have used some sample data that are available in the Gaggle, and for real world your cases, right? Then you will be having data, right? And suppose somebody is asking for academic purpose, there are a lot of sample data available in the Gaggle and GitHub, right? That we can directly download it. Some of the links also I have given. The Gaggle is the one source where you can see all kind of sample data for academic purpose. Okay, but real world use cases, typically the data will be given by the customer, right? And the people who want us to do the topic modeling for their own data. So the data will be given by them, right? And the data may reside in maybe the flat files, or it may be in database, right? And then we will extract the data into flat files, and then we can start doing the processing. Right? For academic purpose, a lot of data available in the Gaggle.
Let me also give an answer for this. Let me also give answer for this by adding a value to the Vijayanand's. I think Professor Teresa, you have raised this question, right? Yeah.
Yes, sir.
Actually, madam, how we academic people will do this, that is what I'm going to cover now. You can use that. I will also share the codes with how Vijayanand has explained you. So where we can get the data is Twitter is one source of taking all those data. For example, let me tell you, last Diwali, I think, Ola has a massive offer. Hope you can remember. Massive offer, and they provided bikes for the rate of 65,000, I think so. Okay, and what happened? So many complaints about the bikes were happened, and all the complaints and the people's issues you can see in the Twitter with like Ola complaints. So there are with some popular hashtags as came EV issues. So what happened? There were some more than 1 lakh tweets were there against the Ola. It was happened. What some of the researchers have done is they have collected all these tweets which is related to this uh, hashtags by writing a separate coding. There is a package called Tweepy. This is one of the Python package. You can write this code and you can have a API access with the Twitter. Okay, it's a payable. Some of the institutions which is having big data analytics, they already have it. You can use this Tweepy and you can collect all these 1 lakh tweets. All these tweets can be processed into the topic modeling, how Mr. Vijayanand has run it, and types of complaints into so many clusters. If you have 5 topics, yes, showed k is equal to 5. I think 5 types of complaints will be segregated, and you can give this to Ola, stating that this is how your complaints can be issued. So, what is the basic logic behind the topic modeling is it will give you the hidden things. I think I answered your question, Professor Tanser.
Yes, sir. Yes, sir. Thank you.
Fine. So Twitter is one such space, and yeah.
Sir, good evening, sir. Sir, shall we use the downloaded document, that is CSV file from Scopus as well as Web of Science directly?
Yes, madam. I'm just coming for that. May I know who raised this question?
Shiva, sir.
Professor Shiva. Okay. Yeah, Professor Shiva, you can see that you can use the CSV file. This is one new form of doing the research. You can collect the scopus.csv files from Scopus, and you can write a systematic literature review by finding the existing literature available in the Scopus files. You can do with the help of Scopus. You can take from Web of Science. So these are the two platforms which are already available, but both are a paid version. You can see my screen now. Since Professor Shiba has raised this, you can see one of the research paper, which is written with the help of.
Your screen
is not visible. I'm sorry.
Yeah, we'll stop my share.
Oh, sorry. All this time I was typing something. I think you all were seeing it. Okay, right. Hope now you can see my screen. Yeah, I think I have just shared this paper with all of.
Yes, sir.
I shared this paper with all of you. So this is the HR paper. Transformative Artificial Intelligence in Human Resource Management, Enhance the Work-Class Planning with Topic Modeling. So this is, I think you can view this paper. This is an open source paper only. You can read the paper. Just by looking at the paper itself, you can understand what the paper is supposed to say. Just the paper is getting downloading. You can see here. So what the authors have written. The authors from Amrita, they have written this paper. Okay, just a minute. Yeah, you can see how Venugopal has explained about the bird topic model. These authors also used that, and they have selected some of the Scopus paper, I think, that is related to AI and HRM, and what are the decisions they have taken. That is already told in the abstract itself. You can see they have written 2 objectives. One is to identify the focus areas of AI application in HRM. And the second one is to find out the organizational change in augmented AI HRM symbiosis. So how they have done this, they have studied some of the literature paper and they have tabulated this. One such good practice is tabulating some of the good papers, most cited papers like this table, by having the focus area and main findings. And how they have done this, they have searched the paper, they did some data screening, they did some eligibility, inclusion, exclusion criteria using Prisma framework, and they have framed 2 research questions. And after that, they have used all these keywords to download the paper. Can you see here? This is the advanced Scopus query which they have used in the Scopus. Institution which is having a Scopus access, you can copy and paste this in the advanced Boolean operators. So R command alone they have used, and they have yielded 412 papers from the Scopus, out of which they have included 389 papers for the analysis by excluding some of the unwanted papers. So in the topic modeling, they are used to the BERT topic modeling plan, and the results also they have shared. I don't know whether they have shared the diagrams or the tables or not. Let me see that. If you can read this paper, you can understand. So how can we do this very practically? So let me tell you in a very simple step. So this is one simple LDA code. You can see what are all the libraries which are used. The one is Scikit-learn, Matplotlib. So if you want workloads, diagrams, Matplotlib is one of the important package.
Excuse me, sir. Sorry for interruption.
Yeah.
Sir,
Yeah.
you have the same thing like using a CSV file. You just please show us from the step one, like from loading to everything, sir.
Yes, madam. That is what I'm doing.
Yes, sir. Please.
I'm just first telling you what we are supposed to do. Then I will definitely we will show you, right? Okay. You may see here. So these are all some of the first process. So usually in the abstract there will be a word called the and. So these words will not be useful for processing the topic modeling. So these words will be removed. That is what the first step is called, stop words and pre-processing. So this will remove the common words which will not be included in the topic modeling. Second one is text cleaning. These are all some of the prerequisites for running the topic modeling. And next one is it will convert the text to lowercase. Usually, uppercase letters will not be processed in the topic modeling. It will remove the punctuation. It will remove the numbers. It will remove the unwanted spaces. This is one kind of good data cleaning before proceeding. And the third one is tokenization. That is splits the text into individual words or token for analysis. For example, some words, for example, AI, artificial intelligence. So certain words should be splitted for finding the best results. And next one is lemmatization, stemming. This is reduce the words to the root form. For example, running is actually run. So lemmatization is bringing the actual meaning from the phrased letters. So this will be automatically done when we coded all these things. And finally, all these text will be filtered and LDA will be processed, latent Dirichlet allocation. So topic modeling does, yes, one? Yeah.
Sir, all these, the tokenization is lemmatization. We have to type all
We
these
have to code
codes.
it, madam. We have to code it. In our coding, it is already there. It is already there in some of the steps. You can see here. Stop words, it is there. Filtering only the titles, it is there. It is there. Actually, you no need to worry about it. Since we are giving you the template to you, you can run it directly. Only thing, you need to find out how many topics you want. Here in my area, I just mentioned as LDA model, I just made it as 4. If you want 5, you can give it 5. So this is always changeable. Even I can make it over here. You can change.
So except the number of topics, other things remain same.
Other things remains the same. If you have any error, you can correct it here itself because there is something called clean error option, explain error option is here. If you click that, Gemini will run the code and it will alter the code according to your request. But something is you need to understand what is happening here. Simply we cannot run the coding, right? So that is one thing. After finishing all these things, what topic modeling will do? So there are so many topic modelings. LDA alone is not a topic modeling. LDA is one of the widely used method. There are other models called BERT topic modeling is there. But widely academic research we use LDA topic modeling. It will create you the workload, it will assign you the topics, and it will save you the results. And what I do is usually I will create a confidence score whether titles are rightly matched in the right cluster. Okay. Imagine it will give you 0.95 as a topic confidence score. It shows that 95% the topic is rightly assigned. So this is how
Means
I
the
used to
titles are rightly assigned, sir?
rightly assigned. Yes, correct. You may see
Okay.
here we have written one code also for that. Assign the topics to each document. I think whether in this, yes.
So this
There is
confidence score also included in research paper, sir?
It can be written as the line, madam. Not all the topic scores, because for each topic a score will be given. You may see here dominant topic, that is actually the score. So dominant topic, when it is near to 1, it is called dominant topic. That is what we call it as topic scores.
Yes.
We have made it.
Shall
So
I,
for
sir?
the
Ma'am, if you want, you can explain in the methodological part all these things.
sorry, madam.
Sir, as I am explaining her question, sir. If she wants, she can explain in the methodological part all these things.
Okay, okay. Yeah, yes, correct, madam, correct. Now I'm just running this code. You may see here, I just asked her to create a data frame with all the results. And finally, the results would be saved in the CSV format, because we need the results as a CSV, not the output as here. CSV file, we can do some filtration and everything. So we are using upload files. While Vijayanand has run the file, he has written very well the coding with finding the path directly from our system. For your easiness, I have made it a button here to choose the file directly here. So before choosing the file, you just understand our Scopus file. So usually the Scopus downloaded files will look like this. Like how Professor Lim from Malaysia on the day, Sunway Business School, he has explained us how to download a CSV file. That file is already there with all of you. So usually our CSV file looks like this only: authors, title, year, all these things. So what we have written a coding is to read the title and to read the abstract. Only both this column will be taken. So the titles and abstracts will be pre-processed, and cluster of topics will be assigned based on this. So what I'm going to do is I'm just going to run the file. So now we are running the file. So this is the file, Scopus file, which you are downloaded. So if it is a big file, it will take some time, but the percentage, it will be going. Topic modeling is ready now. You can see we got 4 topics. Okay, since I have mentioned it as 4 here, we got 4. If we give 5, it will change to 5. What we have to do is, first we should save all these files very carefully. Word cloud. So usually topic modeling starts with 0. So here we took with topic 1. So I'm just giving it as 1. So I'm going for second one. I'm going for third one, and I'm going for fourth one. So how to interpret this is, it's a big logical connections. You should give some logical connections into it. For example, let me open the first one. You can see how this workload is logically connected. You may see the financial area is highly researched, and you can see there is a good relation between this financial and intelligence. Okay, and you can see technology is playing an important role. So from this we can understand topic 1 is highly related with the technology. It is highly related with the AI. It is somewhere it is discussed, some economic concepts were discussed. So topic 1 is all about financial technology or financial intelligence. This is where we can keep a name for this topic. And topic 2 is all about financial modeling, data modeling. Something is about fraud prediction. There is something called blockchain, anomaly deductions are there, where poor customers, bad customers, fraudulent customers can be identified. So somewhere financial related studies are studying about the fraud. So you can say that topic 2 is all about fraud, modeling the fraud analysis. We can take it out. And topic 3 is somewhere it is deduction about banking and AI. So here we talked about financial intelligence. Topic 2, we talked about fraud prediction. Topic 3, we were talking about, very importantly, banking. And topic 4 is all about machine learning in the financial model. So all the 4 are 4 distinct topics. This is where we are supposed to write and discussions based on each clusters or each topic which is assigned. Now the output file were downloaded. You can look at the output file now. If you look at the output file, the clusters were allocated. Okay. Now what I'm going to do is I'm just going to delete all the unwanted areas. One minute. Okay. If you look at the unwanted areas there, I'm just deleting it, and I'm just bringing only the abstract under the title here, so that easily we can read. I'm just taking all the author's name, everything. So you can see there is only 4 columns we have here. Okay. So let me create a filter here. Okay. Let me see topic wise, smallest to largest. How many papers are here? Okay. So you can see dominant topic. So out of 1,444 paper, highest paper were clustered in 3. That is all about banking, I think. So I think topic 3 is about banking. Okay. And we can find out the topic scores. So if you convert this, as a percentage, it will show which topic it has got assigned. Somewhere, if it is related to 2018, in topic 1, this paper is getting assigned. This is where we used to apply a topic modeling. So how to write a paper based on this? You have to select some research gap based on this. From the workload, you can see undermined research area. Then, based on these papers, you can take the full paper of all these things or abstracts of all these things. You can write a narrative synthesis. Then you can write some implications or discussions based on this. You can give a research gap. So which area is underutilized?
So
you can give a
see that future research questions can be formulated based on
yes,
this?
yes, future research questions. I think research questions should be formulated for each cluster you need to do. So if you look at some of the research papers, they have done based on that. Very importantly, I can share you some of the papers also. Even one paper I can show you which is related to that. Systematic literature review. Now it is very common. It is written with the help of the topic modeling. I think I have clarified yours, but we can see one of the paper how they have written. So in the Journal of Financial Crime, they have written a paper about fraud detection. Literature review itself they have written. You can see how they have written, like how I have done, they would have done. But mostly they would not bring these tables inside the paper. You can see here 2 decades of financial statement. For example, for 20 years, they would have taken the data. If you look in the findings or research methodology, you can see from which year to which year. So, and they have written some narrative synthesis. They have cited the right paper. You can see Don to et al. This is the Professor Lim's bibliometric paper. He showed us, right? So this is the citation of that paper. So they have framed some 9 research questions and they have applied the topic modeling and they have set some of the parameters. And you can see right from 2001 to 21. So that is where they were saying it is a 20 decades. Sorry, 2 decades. They have applied Weaver also, a bibliometric tool. They have made some country-wise mapping. So which country is highly related? You can see United States is highly related with United Kingdom, Taiwan. So these analysis you can do with the help of the bibliometric tools. And they have made the Weaver's author's contribution also. The keyword, like how we made a keyword analysis, they have did that. So they have made the frequency of keyword. And this is where Mr. Vijayanand were explaining you the frequency of keyword. He showed you in diagram. Here they go. Usually in research papers, using of the too many diagrams will annoy the editor in chief, so that they were used the tables. And this is the topic modeling they have used with the number of contributions of the papers. They have made the biggest word cloud here. And they have found out some clusters. See how many clusters they have brought in. So finally, they have discussed all those clusters. And they have made a good thing here. So somebody told that they want this paper. No issues. I can share this paper with you. Okay, I think I'm done for the day now. You can understand what is actually.
Thank you so much. You have explained very simple way for actually for writing the research paper. But again, sir, I will ask, maybe I don't know. My question is need to be asked or not, sir. But like how you run those, like just you go to that collab window, sir, and how you load it and how you run those codes, sir. You please show us once, sir.
Yeah, again we can show you. So after this code is ready, I'm just running it. Okay. So once we run it, you don't know whether it is running or not. Only by this rotational thing you can see. If you want to interrupt, you can interrupt. You can go down. It will ask for a choose file. It will be at the down. You don't know whether it is ready or not. Usually you need to scroll down. Then you need to go. You need to choose your file, upload it. Please patiently wait until it's uploaded. So once it is uploaded, the output file will be downloaded and you can see the download button here. The word clouds and all, it will be displayed at the window which is
And
kept in the
moreover,
bottom.
you can see the executing status also down. So whenever the file is being uploaded, executing status will be shown in the down. Okay?
Yes, exactly.
In Google Colab.
So now you can see all the word clouds are ready here and you can see the topics are getting downloaded. If it's a big file, it will take some time. Once it has got downloaded, you can see it will be here. And finally, the result page is ready. This is only 10% of our research, and another 90% we need to clean it. Co-authors should read all the topics. You should segregate topics among you people. Each one should write one topic. Then you should read the manuscript. So writing this, doing analysis is easy. Writing is a bit tough. Okay, I think we are close. We can close.
Sir, I have a doubt, sir.
Yes, ma'am.
So I ran the coding which is given by Vijayanand, sir. So if you allow me to share my screen, I am getting some kind of... Yeah.
Vijayanand, sir, you also can inspect that.
Yeah, sure.
Your name, Professor, you are Teresa. Okay.
Teresa, yes, sir.
Yeah, but I'm just making us a co-host. You can share. Since it is related to yours, you can answer.
Sir, I ran this coding. So I could able to get only this loading packages kind of message for every code that I run. So I ran this, I could able to get this output.
You can explain, Professor, what is your doubt so that Vijayanand can also answer.
Actually, I've just given 4 lines of code where you're downloading the packages. That's why you've got a message like this.
Okay, ma'am. But for this coding also, the df.head also, I could able to get this output. I could not get. Yeah.
No, it is showing some deprecated warning of the packages. So if you go at the top right, there is a command to
Yeah,
suppress
maybe in the middle I have got like I got the output for head of.
Yeah. So if you go to the top of the notebook, right, there is a command we added to suppress these warnings, right? Can you go up? After the package install,
okay.
Can you come down the next? Yeah, there is the second one, right? The one. Yeah, can you run this one?
Yes, sir. I ran this also. So for this also, I could get.
Can you run it again? Yeah. So now you can go and run it, and it will not show any warnings. So it will show the actual data.
Oh, okay.
Because some of the libraries are deprecated warnings it's shown. So if you run it now, then it will not show the warnings. Yeah, now it will show the actual output.
Oh, okay. Yes, sir. Yes, sir. So I could get the
Yes, yes.
Yeah, thank you, sir. Thank you so much.
Okay, no problem.
I think we have explained you a lot. I think Vijayanand gave a technical touch from the industry side, and we have explored from the academic side, I think. Any doubts is there? Otherwise, we can close the session. Professor Anu?
Yeah, thank you, Vijayanand sir. It was a wonderful, informative session.
Yeah, thank you so much, Anu ma'am, Murali sir, for giving that opportunity to present it.
Thank you.
And you started from scratch. Generally, people from industry, it will be very difficult for them since you work with advanced analysis. So you started from scratch, and our participants, I think all of them understood well. Thank you so much, sir.
Today they have understood both the perspective. One from how the industry person will teach, and how we can teach from our side, from the academy. I think they have got perspectives. Right. So thank you very much, Vijayanand. Thank you. Venugopal was also there.
Yeah,
thank you very much.
Thank you.
Thank you. Bye-bye. Have a good evening.
Thank you. Thank you. I think Professor Dr.
Vinod sir has joined. Yeah.
Join. Fine. Hello, Dr. Vinod sir.
Yeah, I'm here. Can you hear me?
Yes,
Yes,
sir.
sir. We can hear. For a while, please come in a video. We'll have a screenshots and everything.
Yes,
hello, sir. Good evening.
See you.
Good evening.
So good evening, everyone. So it's my privilege to introduce our distinguished guest and speaker, Mr. Vinod Venkateswaran, Senior Industry Principal at Infosys, a global leader in technology, consulting, and engineering services. So Mr. Vinod brings with him over 28 years of extensive experience across technology consulting, engineering management, and operations, consistently driving innovation and delivering business results. Throughout his career, has established new service lines and P&L models, defined go-to-market strategies, and set up innovation centers that help clients experiment with emerging technologies and create immersive customer experiences. At Infosys, he has successfully led global delivery units with multi-million-dollar revenues, nurtured strong client relationships, and driven operational excellence. So his expertise spans technology strategy, product and innovation management, IoT, cloud and analytics, and connected vehicle technologies. A recognized thought leader, Mr. Vinod has been honored with multiple awards, including Technocrat, Best Thought Leader, and Innovation Excellence at Infosys. He has also published several insightful papers on topics such as AIoT transformation,